Hi, and welcome to a recording which illustrating some of the features of Sonic Pi 3, which I built from GitHub. And I want to introduce you to one or two of the features which are in it. First of all, we're going to play some MIDI, and that's going to drive an external synth. We're actually going to use GarageBand, which is freely available with a Mac. And we're then going to take the output of GarageBand and feed it back into Sonic Pi as a live audio stream. We're going to use another new feature in Sonic Pi 3, which is the fact that there is a built-in WithFX record function, which you can record to a buffer in Sonic Pi. It actually records to a temporary file, WAV file on the Mac. And you can then subsequently use these buffers and play them back and manipulate them as part of a Sonic Pi program, which is the third part of what we're going to do. So let's look at the program. It starts off by setting use BPM, beats per minute, of 60. I've done this so that I can easily interchange between seconds and beats for timings, because 60 beats per minute is 1 beats a second. The next line will be a new one, and that is that we're going to define two buffers. Buffer B1, which is going to have, it's got comma 4 after it, and that means it's going to last for a duration of 4 beats, or 4 seconds in this case, and buffer B2, which likewise will last for 4 beats. And I put these both into a list, an array, RB. This is going to make it much easier to refer to them without having to type out all the buffer stuff each time we want to use them. And because I want to use two buffers and use them in different stages of the program, it's easier to specify them like this at the beginning. Then we move on to a MIDI section, and this is a standard live loop, as you might have in an earlier version of Sonic Pi, with the exception of the line which is going to play the MIDI output. We've got C equals aux C2, 4, and what the aux function does is to produce a series of octaves of a given note, the number of that are given there. So we'd have C2, C3, C4, C5, and it's arranged as a ring. So if we put dot tick after it, each time we go around this live loop, then C will get one of the next notes in sequence. So it goes C2, C3, C4, C5, C2, C3, C4, C5, and so on. That is fed out as a MIDI note, and it lasts for 0.2 seconds. It's sustained for 0.2 seconds, and it's coming out of MIDI channel 1. There's channels 1 to 16 available. I've not specified a MIDI device, so it will go out to any device which is available, and it'll be picked up by GarageBand. Then the output of GarageBand is going to come in as a live audio feed, and that's in the next line. The syntax is live audio, then the name of the audio feed. I've called it :GB because it's coming from GarageBand. Then I've specified an amplitude of 4. I've boosted it up a bit, and it's going to input 3, and because it's got stereo true after it, that will be inputs 3 and 4. You may say, how do you get 3 inputs or 4 inputs in a Mac? Because normally in sound preferences, there are 2 input audio channels available. And usually the only thing you can feed into them on a standalone Mac is going to be the internal microphone. But I've got a little program added here in the background called Loopback. And Loopback is a very interesting program. It lets you make virtual devices which you can either use as a sort of feed-through device, so you can feed the output of one program in as an input and take the output and feed it to the input of another program or wherever you want to send it. You can also modify this loopback device, and you can put inside it built-in sources that it expects, and you can then generate a number of channels that it will do. It's a sort of aggregate device. And in this case, I've got 10 channels which I've used, and I've put in all the things that I'm liable to use with Sonic Pi. The built-in microphone I've left on channels 1 and 2. Eddie Roll is an external hardware audio capture 2-channel device, which I've got a handheld microphone fed into. So we're just going to use the left channel of that. and that is actually, I think, in channel 9 up here. And the only other thing we're using in this particular program is GarageBand, and that's being fed in, as you can see down here, to channels 3 and 4. So that's where these numbers come on this side of the program. If you're interested in this program, Loopback, it's actually quite expensive, certainly in comparison with, it's more expensive than buying your Raspberry Pi, for example. But if you download it, it will run in a sort of demo mode for up to about 10 minutes before it puts white noise on the audio. And so that's probably quite long enough to do quite a bit of recording with the Mac. So you might care to have a look at that. Loopback. It's from a firm called Amoeba, I think it is. So we'll just leave that in the background now. And here is the synth we're going to use. I've specified, just taken the synth marimba in GarageBand, and it's very simple. GarageBand will just accept any MIDI input that's coming in, and it'll feed it into that. And we specified the output in the preferences for GarageBand up here, so that it goes to the loopback audio device that we saw over here. And that is going to then feed it out input channels 3 and 4, which is how it gets back to the to Sonic Pi. So let's bring Sonic Pi to the front. There we are. And we'll just simply play the program, and what you will do is you will hear the output of that marimba in the live audio coming back in here. There it goes. You can see the MIDI notes being sent out on the right-hand side here, and you can hear the audio, and you can see the audio on the scope trace at the top there. So we'll stop that. We'll have to perhaps just have a look at, you can see it's all functioning here in GarageBand as well. Let's just stop that running now. Now that we've decided what we want, we can get rid of those two lines, which are just temporary, so that we can hear what's there. And instead, we're going to uncomment the next part of the program, which is here. And what that's going to do is, when we start the program running, it's first of all going to sleep for 4 seconds. That's just to let everything settle down and make sure there's no glitches in starting up the GarageBand. And then we're going to, at that stage, have the FX record function in here. And that's going to record into the buffer in RB0. That's the B14 up at the top here, this buffer. And it's going to feed into it the live audio coming from GarageBand, as we've already seen here, in input channels 3 and 4 stereo. And then that's the FX loop, which is going to do the recording. We start that going, we sleep for a further 4 seconds, and then we say live audio GB stop, and that stops that audio feed, so it stops the recording. And well, at least there's no input coming to the recording. But at any rate, we've reached the end of the buffer, which is 4 seconds long, so that lets us fill the buffer and then stop. And then at our leisure, we can stop the program running. It will actually stop executing any commands there, but the live loop will still be running until we press the stop button. So let's record that. You'll see activity in the right-hand side. You won't hear anything for 4 seconds. Then you'll hear the 4 seconds of the recording, and then we'll stop it. There's the recording. 4 seconds and it stops. The MIDI loop is still running, but we just stop the program, and that's all done. Now, we're going to record into the second buffer, which I do simply by changing RB0 there to be RB1, but we're going to change what it's getting. I'm going to bung up the starting position of the octaves by 1, so it starts at C3 instead of C2, and I'm going to reverse the direction of the notes by simply doing that. So we're recording something a little different, but exactly the same program. We're going to record to buffer RB1, which is the buffer B2 there, and here we go. 4 seconds pause, nothing to hear. And there's our 4-second recording, and we stop that. So we've now done our recording, and at this stage, just before we go on, I'm going to do one other thing, which is temporarily to put in puts RB0. What is this buffer? Where is it? And so on. And I thought it'd be constructive just to have a look at this. So we'll just run that. Remember, we've recorded these. So it knows about them. And here we have the details of the buffer on the right-hand side. And you can see that stored in that variable, we've got the buffer ID 2. That just tells Sonic Pi internally where it is. It's a 2-channel one. That's its duration in frames, because we're having a sample rate of 44,100. It's a duration of 4 beats. And the interesting bit is the path at the end here, which tells you that it's actually being stored in a temporary location in Sonic Pi. It will actually be destroyed when you quit Sonic Pi, but it'll stay there till then. And it's stored in that temporary location, and it's in the WAV file B1 at the end there. So you could actually get it by simply copying that and then using that to retrieve the sample. I think in the later version of Sonic Pi, there will be the opportunity to save these buffers. I think Sam said it might well happen automatically, and we'll just see whether that, when that comes along. But that's how you could get it if you want to. So we'll just get rid of those which we don't really want, and we'll move down to the second part of our program. We're simply going to get rid of all the live loops, all the live loop MIDI stuff and so on, and the recording, because we've done the recording. We've got our buffers up here, and we can refer to them in the second part of the program. And this is the playback side, if you like. First of all, we have a live audio feed, which is boosted slightly in amplitude there. And we're using the microphone input in channel 9. That's through my Eddie Roll external device, and I've got a handheld mic, and I might be persuaded to sing along with this once it gets going. Then the main part of the program, which we've got a level setting of 0.84 down to there, is a live loop which I call PL. And what that's going to do is simply play our samples and manipulate them. It plays them, first of all, straight through sample RB0. Remember, it's 4 beats or 4 seconds long. So we sleep for 4 and then play RB1. We sleep for 4 and then we play RB0 at half its normal rate, which means it lasts twice as long and it's at half the pitch. Well, I only want 4 seconds worth, so I'm going to start at 0 and finish at 0.5 halfway through. The same for RB1. Then we play RB0 at twice the rate, so it's going twice as fast, double the pitch, and it'll only last 2 seconds. Sleep 2 seconds, play RB1, sleep 2 seconds, RB0 again, sleep 2 seconds, RB1 again, both at rate 2. And so we've got 3 sections of 8 beats. First of all, normal pitch, secondly, half pitch, and thirdly, double pitch. And then to accompany the whole thing, we have a bit of programming which could have been done in an earlier version of Sonic Pi. We've got 2 rings which are going to specify the timings for playing a sample drum bass hard and a sample drum cymbal close samples built into Sonic Pi. And every time there's a 1 there, it's going to play. And so it says if db.tick is equal to 1, it'll play the drum. And if it, cb.look is equal to 1, it's going to play the drum cymbal. And that will simply go around giving us a rhythm track, and I put a bit of reverb around it to make it sound a bit more interesting. So we're ready for the playback of the whole thing. Here we go. Playing both samples at normal rates. Change the second one there. Now it's going half rate, half the sample. Change to the second one. Now double rate, change sample, double rate again, change sample, back to the beginning. And now I can join in myself. Turn up the amplitude of my handheld mic. Well, I'm not doing anymore, embarrassing myself anymore with that, but you can see it can be done. So there we have it. Playing MIDI, external synths, bringing sounds into Sonic Pi, recording them as samples, and manipulating those samples to produce quite a nice, effective track that would be the bass for whatever you want to do on top of it. Could be an instrument, could be a microphone singing, anything you like. Let's stop Sonic Pi, and then we'll stop the video. Thank you for watching.